So let's look at the Lewis structure of the sulfite ion and go through the steps of how to draw it. So I broke my stylus earlier today, the tip of it, and so I'm going to try to draw these with my finger. So I'm going to just, you might have to just also listen to the words I'm saying in order to like read whatever it is I draw. Okay, so let's look at the sulfite ion. So sulfur is going to be our central atom, and let's tally up the number of valence electrons. So we have 6 from sulfur, and then we have 18 from oxygen. So that's 24, and then we have an extra 2 electrons because this is an ion. So that means that we have 26 valence electrons that we need to deal with. So we're going to start out by drawing sulfur as our central atom, drawing the 3 oxygens around. Now, from these 3 oxygen bonds, we've used up 6 of our valence electrons, but we have to use up the other 20. So I'm going to start by putting electrons on on terminal atoms in order for them to get an octet. I'm going to start with this oxygen in the bottom right here. I'm going to make these electrons a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's still 2 more to assign, so I'm just going to put them on the sulfur. So now we've assigned all of the valence electrons according to the octet rule. But if we look at the formal charge on each one of these atoms, one of these oxygens is going to have a -1 formal charge. So oxygen has 6 valence electrons. Each one of these oxygen atoms is assigned 7 electrons. So 6 minus 7 is -1. So each one of these oxygens has a -1 formal charge. And then the sulfur, also in group 6, this sulfur has 1, 2, 3, 4, 5 electrons assigned to it. So it has a +1 formal charge. Okay. So since the central atom has a +1 charge, and we have lone pairs on some of these terminal atoms that could be used for making a double bond, I think that we're going to try that. Try pushing some of these electrons on these terminal oxygens in to double bond with sulfur, and we're going to see if we can't get this central atom to be neutral and an overall lower formal charge of all of the different atoms that make up this molecule. Okay, so I'm going to do that on next slide here. So we have sulfur, and it's 3 oxygens. Sulfur has a lone pair. Let's draw all these electrons on the oxygens. Okay, so what I'm going to do is I'm going to push one of these electron pairs in to bond with sulfur. And if I've done that, right, I'll have a molecule that looks like this. And now, if I calculate the if you calculate formal charge on all of the atoms, these ones that are singly bonded still have a -1 charge. And then let's calculate for this oxygen that has a double bond now. So oxygen is 6 minus, there's 6 electrons assigned to it. So it has a formal charge of 0. And then this sulfur here, also in group 6, has 1, 2, 3, 4, 5, 6 electrons assigned to it now. So it's going to have a formal charge of 0. Because this sulfur atom and this oxygen atom now have a lower formal charge, this is going to be the best structure. So we did 2 different things here. We looked at formal charge and we looked at the octet rule, right? So our structure using the octet rule was different than the one that we found using formal charge. The one that we found using formal charge is going to be better or more correct. Now, in addition, this oxygen, or this ion, the sulfite ion, has a total of 3 structures, right? This is going to have a resonance. So I'm going to demonstrate the resonance over here. So we have one structure that looks like this. Okay. And then, just to illustrate what can happen, push those electrons in to bond with sulfur, and this pair of electrons can get pushed back up to this oxygen. So we can have this resonant structure. It turns out it's really hard to draw these electrons with just your finger. Alright. And it doesn't matter where I put these lone pair on the sulfur atom, right? It just matters that they're there someplace. Okay, so this is one resonant structure. There's another resonant structure, and it's if this other oxygen uses its lone pair to double bond with sulfur, and then these electrons can get pushed back up onto that oxygen on the right hand side. So we'll have this as a resonant structure. And because this is each one of these results in the same sort of set of formal charges, there's not one of these that's a best structure. So it's going to resonate between all 3 of these structures. But all 3 of these structures would be the correct resonant structures and Lewis structures for the sulfite ion.